Hi everybody, and once again welcome. And this is continuation of my series of videos on grade 7 IGCSE students. Subject is science, and the topic or the chapter number is chapter number 8, and name of the chapter is chemical reactions. Okay, so this is for grade 7 students, and it's for the science students. Okay, I mean science is the subject. And in the previous 5 lectures, I have covered at least 50% of this topic. Okay, so let us continue. And this being lecture number 6. So let me start from question answers on endothermic reaction. Now, already I have explained in my previous 5 lectures what is exothermic reaction, what is endothermic reaction, and what are the examples of these two reactions. That also we have discussed. Then we have also discussed about the application of this endothermic and exothermic reactions, and all that we have completed. Okay, now let us get started with the question answer session, and these are the question answers from your textbook. Okay, learner's book, right? So starting with question number 1. Now if it is okay, or let me magnify it a little bit. Okay, yeah, now it's fine, right? So let us start with the question answers. Okay, so I'll be using green tick mark so that you can. Okay, yeah. So this is question number 1. When you see this, question number 1, we are starting with this, right? Okay, now the question says that look at the word equation. Okay, and the word equation is given here: sodium hydrogen carbonate plus citric acid gives you sodium citrate plus water plus carbon dioxide. Okay, now this is the word chemical equation, and sub question A is what are the reactants, and sub question B is what are the products. So as you know, everything on the left hand side of the arrow mark are nothing but the reactants, and everything on the right hand side of the arrow mark are nothing but the products. So the answer for A is what are the reactants. So the answer for the reactants will be sodium hydrogen carbonate and citric acid. So answer I have written here. Can you see? Answer for A is sodium hydrogen carbonate and citric acid. These are the reactants. Now for sub question B, what are the products? Okay. So for B, the answer is sodium citrate, water, and carbon dioxide. So answer written here is sodium citrate, water, and carbon dioxide. Okay. So these are the answers for question number 1, A and B. Now let us move on to question number 2. This one. It says that what is an endothermic reaction? That's it. Okay. So you have to just write the definition of endothermic reaction. So here the answer for 2 is a chemical reaction in which heat is absorbed and the temperature of the surrounding is decreased is called as an endothermic reaction. So you have to just write the definition. Okay. So for endothermic reaction, the important points are heat is absorbed. Okay. Temperature of the surrounding is decreased. Okay. And these two are the important points. And such chemical reactions in which heat is absorbed and the surrounding temperature is getting decreased are nothing but endothermic reaction. Let us move on to next question, question number 3. This one. Okay. It says that explain why eating sherbet sweets make our mouth feel full or fuller. Okay. So why by eating sherbet seeds, okay, or sweets, okay, our mouth feels fuller? That's the question. So answer for that is, answer for this third one is, now the sherbet sweets contains citric acid and sodium hydrogen carbonate. Okay, so the reactant of this particular equation, okay, the very first equation that we discussed, those are already contained in this sherbet sweets. Okay, so sherbet sweet contains citric acid and sodium hydrogen carbonate. Okay, and when we eat this, when you eat this sweet, okay, this substance is combined with the water present in the saliva. So when we eat, okay, this sweet, This sweet already contains sodium hydrogen carbonate as well as citric acid, and in the mouth our saliva contains water. So water is also reacting with this other two content of the sweets. And what will happen? This particular reaction will take place, which is nothing but an endothermic reaction. Okay, so this water present in the saliva, they all will react to undergo an endothermic reaction. Now this is an endothermic reaction which takes heat energy. Now endothermic reaction will take heat energy. It will absorb heat energy. So this being an endothermic reaction, it will try to take heat energy. Now from where it will take heat energy? It will take heat energy from our mouth. Okay. So it is an endothermic reaction which takes heat energy from your mouth. Okay. And this gives cooler feeling in the mouth. Okay. So because the heat energy from the mouth is taken away by the reaction, okay, or the heat energy of the mouth is decreased, okay, therefore we get that cooler feeling on eating this sherbet sweets. So that's the answer for question number 3. Now let us try this question number 4. Question says that you may also get a fizzy feeling in your mouth when you eat sherbet. Why is this happening? Okay, now since we have discussed in question number 3 in that answer, when you eat this sherbet sweet, there's an endothermic reaction taking place between citric acid, sodium hydrogen carbonate, and the water from the saliva. Okay, and the product, one of the product formed is carbon dioxide. Can you see here? Carbon dioxide is also formed, right? So because the product formed is carbon dioxide, and carbon dioxide, you know, it will give you that fizzy feeling in the mouth. Okay, so for carbon dioxide, you know, is a gas which will try to escape from your mouth, and that that carbon dioxide formation in the mouth will be seen as effervescence in the mouth. Okay, which is giving you that fizzy feeling. Okay, so this fizzy feeling that you get on eating this sweet, sherbet sweet, is because of the formation of the carbon dioxide as one of the product. Okay, carbon dioxide is formed, which is responsible for giving that fizzy feeling in the mouth. So these were the first 4 questions that I have answered for you. Now let us move on to the next question, that is question number 5. Okay, so I'll take you to the next slide. Okay, so here you can see question number 5 over here. Okay, this is your question number 5, and let me read the question for you. Why is ice melting called an endothermic process and not an endothermic reaction? Okay, very good question. Now melting of an ice is called as an endothermic process, not an endothermic reaction. Why? The answer is ice melting. Here is the answer. Ice melting does not result in the formation of a new product. So when the ice is melting, you don't get any new product formed. Okay, you don't get any new product, right? So a new product is not formed, and hence it is not a chemical reaction. So it is not a chemical reaction because a new product is not formed, right? There's only a change of state taking place from solid to liquid. Okay, but the heat is absorbed and the temperature of the surrounding is decreased. But in this process, okay, it's just a change of state. It's not a chemical reaction because new product is not formed. Okay, only the state is changing from solid to liquid. So change of state is a physical reaction, not a chemical reaction. So it is not a chemical reaction, but it is a physical change, and that is why we can call it as a process. And the heat energy is absorbed and the temperature is decreased. So absorption of heat energy is taking place and the surrounding temperature is getting decreased. And because of these 2 points, you can call this as an endothermic process. Okay. So because heat energy is absorbed and the surrounding temperature is decreased, it is an endothermic. And because it is not a chemical reaction, it is just a change of state. So we will call it as an endothermic process and not a endothermic reaction. Okay. So that should be your answer to this question number 5. Question number 6 is that suggest a change of state other than the melting of ice, that is an endothermic process. So just like melting of ice, can you suggest one more process which can be used as an example of this endothermic process? So the answer for this is yes. Change of state from liquid to gas. okay, or in that case you can say from water to vapor. Okay, so change of state from water to vapor, or in general from liquid to gas, is nothing but you can call that as evaporation. Okay, and this is also an endothermic process, because here also no new product is formed, so it is not a chemical reaction, but there's only a change of state, and change of state is taking from liquid to gas. Okay, and it is endothermic because here also you will see that the heat energy is absorbed and the surrounding temperature is decreasing. Okay, so change of state from liquid to vapor, or from water to vapor, okay, is a good example of endothermic process. Okay, so that is the answer for question number 5, right? Question number 6. Okay, now question number 7. Let me read out the question for you. When you have been swimming and you come out of the pool, you may feel cold. Now use your understanding of the endothermic process to explain why. Okay, so once you are in the swimming pool and when you come out of the swimming pool after some time, okay, you feel very cold. You get a cold feeling. Okay, now why this is happening? Okay, give the answer to this by the understanding of this endothermic process. Okay, so the answer for this 7th question is this. When you come out of the swimming pool, the water particles on your skin, okay, the water particles will be sticking to your skin still. Okay, so these water particles, they take heat energy from your body itself, okay, to get converted to vapor. So heat energy is taken from your skin, from your body, and those water particles get converted into vapor. They evaporate. Okay, now this is an example of liquid that getting converted to gas. Okay, so water particles on the skin are getting converted to water vapor. Now in this process, what is going to happen? Because it's an endothermic process, you know that liquid to vapor is an endothermic process. Okay, so because it's an endothermic process, it is going to absorb heat. Now from where it is going to absorb heat? The water particle is going to absorb heat from the body, so the body temperature will decrease. Okay, so there is absorption of heat taking place, and there is also a reduction or decrease in the temperature of the body. Okay, because of these two, this is an endothermic process. Okay, and that is why the person who is coming out from the swimming pool, okay, feels cooler, right? That was answer to question number 7. Now question number 8 is this one. Suggest whether water freezing is endothermic or exothermic process. Can you explain your suggestion? So the suggestion is that water freezing is not a endothermic, but it is an exothermic process. Okay, so answer for this 8th one is water freezing. Now in water freezing, what happens? In water freezing, water is converted into solid or ice, you can say. Okay, so this is reverse that is happening. Water is getting converted into solid. Now here the heat energy will not be absorbed. Okay, it will be given out, because this is a exothermic process, right? So water freezing is an example of exothermic. Should I write process? Okay, it should not be reaction. It should be process. So let me do that correction. Okay. Okay. So it's a process, right? Exothermic process. Fine. Okay. So water freezing is an example of exothermic process because the water molecules come closer to form a solid ice, and this happens by release of heat energy. In exothermic processes, heat energy is given out or released. Okay, so the answer for this question number 8 is the freezing of the water is not a endothermic but a exothermic reaction. Why? Because here the heat energy is released. Why heat energy is released? Because the water molecules are getting converted into solid ice. Okay, so if this is a process where the molecules are coming closer to each other. Okay, so it's a process in which heat is not absorbed but heat is released, and therefore freezing of water cannot be an endothermic reaction but an exothermic reaction. So this was the answer for question number 8. Now let us complete this 9, 10 and 11, three more questions. So for that I'll change the slide, and here we go. So now let us see question number 9. Now you can see this is 5, 6, 7. Okay. 9, 10, 11. I've taken a wrong slide. Yeah. Okay. Now, one second. 5, 6, 7, 8, 9, 10, 11. Yeah. Yeah. So this is that slide which shows question number 9, 10 and 11. So, but I've somehow, let me do some correction. This is the wrong thing. Okay. Now question number 9, 10 and 11. Now the somehow, questions I could not put it on this. Okay. But I'll do one thing. I'll read out the question for you. I can get the question also over here. Yeah. I'll get the question, right? No problem. Give me just 1 second, right? Okay, let me do one thing. I'll read out the question, or I'll write the question for you, and then we can discuss the answers. Okay. So question number 9, I'll write here. Okay. From the textbook, it says that explain using particle theory. I'll write that for you. Explain using particle theory why the reaction okay, let me do one thing. There is some mess over here. These question answers are not matching. Okay. Now I'll do one thing. Today's lecture I'm going to end here only. So let us take for granted that this video number 6 is only ending at this particular point. That is, we have discussed some 5, 6, 7 and 8. Up to 8 we have discussed the questions. Okay. 9, 10 and 11 is still there, but that we'll discuss in the next video. Okay. So that's all for today. See you. Bye.